Okay, so P10.3, forces and braking. On your data sheet you are given an equation, which is a bit more complicated than your normal equations, which is why you're given it, which is v squared equals u squared plus 2ax. And what that means is, it means that the velocity, and v means end velocity, equals start velocity. Don't forget to square these two. Plus 2 times the acceleration times distance. Okay, and the other bit that you need to remember is you need that you need to have brackets on here, because you do this squaring bit first and then add it to 2 times acceleration times the distance to work out what the end velocity is squared. Okay, and the reason why this one is useful is because we can use this to work out how long it's taken us to stop, okay, or how far we go before we stop. And if you're thinking about stopping, then you know that your end velocity v is going to be 0. So if we're talking about stopping, so stopping, then u will equal, then v, will always equal 0 if you're stopping. So then you can say that 0 equals u squared plus 2as. And then we can just rearrange this slightly, so we can say that u squared equals minus 2as. And all I did there was take that to the other side by minusing 2as from both sides. And then let's say we know that we're travelling at 10 meters per second. So if we said that u equals 10 meters per second, and we said that we know that we want to try and stop in 10 meters, let's not go for 10 meters again, let's go for 5 meters this time. We want to stop in 5 meters, so s equals 5. What kind of acceleration will we need in order to get that stop in distance? So we write a question mark, and then we say 10 squared equals minus 2 times 5 times a. So that means that 100 divided by minus 10 equals a, which means that a equals minus 10 meters per second. And all that minus means is that you're slowing down rather than speeding up. Okay, so that would be a way of using that equation. And if you knew what your mass was, so if you said that your mass equals 1,000 kilograms, you could also then use F equals ma to work out how much force it took you to stop. So you then say that F equals 1,000 times minus 10. So it's saying that you need 10,000 newtons, and the minus just tells you the direction. So in the opposite direction to the one you are travelling in. Okay, and well, this is interesting, because what we've just discovered is we've got a force and we've got a distance, and if we remember from our previous module, we know that work done equals force times by distance. So then that's your 10,000 times 5 to give you 50,000. So you can work out what the work done is as well if you wanted to, so 50,000 newton meters. And that's how much work you would have to do to stop the object of 1,000 kilograms, which is currently travelling at 10 meters per second in a distance of 5 meters. Oh, and it gets even better. We can carry on. We know that that must be, that's the kinetic energy that it had to start with. because you know that however much energy you need to stop it is how much energy you must have had to start with. So you know that it must have had 50,000 joules of kinetic energy to start with. And then if you rearranged all that and did half mv squared, you could get back to the fact that V must be 10, which is quite handy. And if we wanted to work out the power of the brakes, let's link it all up. Why stop there? And we said that the power equals energy divided by time. If we said we stopped in 10 seconds, then we would say that 50,000 divided by 10 equals 5,000 watts. And that would be the 5,000 watts would be the power of the brakes. So let me just take you through that from the top, because that covers pretty much the whole of this course. So, equation that you give in the data booklet, v squared equals u squared plus 2as. And we said that v squared is end velocity squared and u squared is start velocity squared. And we said that if you're stopping, then v is always 0, because end velocity would be 0. So we can say that 0 equals u squared plus 2as. Just take the 2as to the other side, so we get u squared equals minus 2as. And that minus just means the acceleration is negative. So if we want to put some figures into that, just to give you as an example, we could say that if you had a start speed of 10 meters per second and you wanted to stop in 5 meters, what would your deceleration have to be? So 10 squared minus 2 times 5a. So that means that the acceleration is 100 divided by 10, and that's negative, which tells you it's a deceleration. And then we say, well, if we know what the mass of the car is, or the mass of whatever object it is we're talking about here, and let's say we say that was 1,000 kilograms, we can work out how much force it's going to need to stop that object. And that's just provided by what we did last lesson, which was mass times acceleration. So if I take the mass times by the acceleration, I'm going to say 10,000 newtons in order to stop that. And the minus sign here, where the minus sign previously meant deceleration, well, the minus sign here just means that the force has to be acting in the opposite direction to that you're currently travelling. If it was in the same direction as the way that you're currently travelling, you'd be getting faster, not slower. Okay, so, and then we said, oh, hang on a minute, we've already used force and distance, so what I can do this time is I can do the force, which we worked out was 10,000, times by the distance to give me 50,000 newton meters. And that must be the kinetic energy that we had to start with. So however much energy it takes to stop it is the same, which is the work done in stopping it, is the same amount of kinetic energy you had to start with. And if I wanted to then work out what the power of my brakes was, I would just simply go energy divided by time. So the energy was 50,000 joules. I divide that by 10 seconds, because I just said I want to stop in 10 seconds time. That would give me 5,000 watts. And you could work that out for anything now, just by linking it all together. And hopefully that shows you how it starts to link